tomorrow evening. If you all take an action, a small action, even if it's not a big one, we are talking about more than 900 actions that will be split into more than 70 countries. And that will make this conference worth, that will make the efforts we all made to be here today worth. So thank you for being here today. Welcome. So now, the big players, okay, our keynote speakers. First one is Bart Rienties. Bart Rienties is Professor of Learning Analytics and Program Lead of the Learning Analytics and Learning Design Research Program at the Institute of Educational Technology at the Open University UK. He's President of the Society of Learning Analytic Research, SOLAR, the largest researcher community on learning analytics. Sir, floor is yours.
So how are you this morning? Are we all right? Good. Just a warning, every time when there is a screen that turns orange, that means interaction. So you will have to do something. So apologies in advance if you don't want to participate, but I hope you will enjoy this a little bit. So what I would like to do today, and I was really touched by Antonio with his message from Valencia, and I totally agree with him that life is a constant change. So what I would like to talk to you about is what we've learned from 15 years of implementing learning analytics within SOLAR, but also particularly the Open University where I'm from. Yes, I will briefly talk about AI, and if there is time left, I would like to talk also a little bit about learning design, but if there is no time left, that's also perfectly fine. So there is this fantastic meta-study by Hernández de Mendes, and they looked at 17 large universities across the globe to see, okay, how have they implemented learning analytics? And in their study, they identified 3 big pillars, and I would like you to think about, okay, how is your organization focused on one of those pillars? And afterwards, I would like you to vote. So the first group of universities primarily focus on learners. So they've used data, they use data to inform learning analytics, and it's primarily used to measure, for example, the engagement of students, to enhance their engagement, thinking about how to personalize their learning, improve their learning outcomes, and perhaps linked also to PAT, giving this data to parents of children and thinking about how they can improve their learning. The second pillar is mostly focused on staff. So how learning analytics and data can, for example, enhance assessment, allow teachers to give real-time feedback, make more efficient interventions, for example, monitoring their students, et cetera, And the third pillar is focused more on identifying where in my organization is there good practice. Where in my organization is there perhaps not so good practice? And basically, they are using learning analytics more on a kind of macro level to improve the learning design. So if I do a raise of hands, which of you thinks that mostly in your own institution, you primarily are focused on learners in terms of using data? I only see a couple, okay? 20, 30, 40, 50, okay. Which of you thinks that you're mostly using data to understand what's happening with your teachers, to help to inform your teachers? 1, 2, 3. I would say probably more or less similar. Who is focusing mostly on the third level, so looking across the institution? A couple. Who has not raised their hand? Okay. So I'm mindful I can't really interact, which is very strange, but come to my session afterwards because I'm really keen to listen to your stories why this is the case. But is there anyone who wants to shout out briefly why you're not using data? Okay, let's come to that session later on. So let's give you a brief insight of my institution. We're the largest university in Europe, and we have a very large group of students that come from a so-called disadvantaged background. 1 in 4 of our students has a disability, mental or physical, and a lot of our students are already in work. So we're open to the world, But that means also, and it links very nicely to Antonio's talk, is that we can't standardize our program too much because people are so different at the Open University. So what we've been doing since 2012, it says 2014, but we started actually in 2012, is we've been giving dashboards to our amazing teachers. And our teachers are basically able to log in to their dashboard to see how our students are doing. And we give basically traffic light, warning signals of how a student is doing well or not so well. And then a teacher can click on each individual student and try to see whether it works or not, and why this particular student is going well or not. So we started in 2013 with 2 teachers. Then we went to 2014 with 10 teachers. And by continuously and slowly learning from those teachers, we went bigger and bigger in terms of upscaling these tools. And in 2018-19, we made this available to 3,500. Now all 5,000 teachers have access to this. But the big conundrum is that only around a third of our teachers are actively using it. We know that every teacher that uses our tool has a 10% higher retention rate. 10%, that's quite a lot. So why are only a third of our teachers using it? The first one, which is not on the slide, I'm mindful that I'm being recorded, is they're not being paid to look at this data, right? So the second and third and fourth and fifth factor is basically we found huge differences in terms of how the university is supporting our teachers with this approach. So in certain faculties, there's a huge encouragement by the senior management and also on the bottom-up approach of encouraging teachers to make use of learning analytics. They appoint the teachers as champions, they allow teachers to generate lots of evidence, etc., etc. So that really drove performance of, not performance is the wrong word, uptake of these tools. But another crucial factor, and I think this links to also the PISA study that Antonio showed, is all this kind of data requires a lot from teachers. And to be able to make sense of all this data requires a lot of understanding of the complexities of data. And a lot of teachers didn't necessarily feel comfortable. So in a range of follow-up studies, we then tried to really unpack 3 or 4 years after we launched this in a range of schools, trying to identify, okay, why are teachers using it and why are they not using it? And we found a quite diverse perspective. So one group of teachers said, yeah, I heard about it, but I didn't feel the need to use it. And when we looked at, okay, what are the kind of themes that they identified, they said, well, there's no training, no one knows about this, I have so many other priorities in life, you know, why bother, right? And then there's a group of teachers that said, I tried it in the past, but I'm not using it in the moment. And again, they identify a lack of training, a lack of understanding, et cetera, et cetera. And then there's a group of teachers who are very active about it. So I guess what I'm trying to say in an ill-articulate way is we as organizations have to think really hard, how can we support our teachers to make use of these tools? Because the tools are out there, and we provide lots of training, but the biggest hurdle is not necessarily the technology, it's about how can we encourage these amazing teachers to actually make use of it. And then even if we make use of these tools, there's a study by one of my former PhD students. She put one of those teachers in a lab, and we basically did some eye tracking with them. And guess what? They made amazing stories about what these students were doing, but that was just not entirely true, because this was not supported by the data. So I guess the story that I'm trying to slowly tell you with learning analytics is learning analytics is a really powerful approach to understand how you as an institution or as an educator can make use of data, but it requires a substantial amounts of skills to make sense of this. And I think this is one of the big challenges that we at the Open University face. Yes, we have all these tools available, but how can we make sure that we provide this in a sensible format to students? So the next part that I'm keen to look at to you is to think about how we can actually focus on the challenges of learning analytics. So there are, again, this screen is again is orange, so this means that you will have to do something. So one big challenge that has been identified in the literature is a notion around ethics and privacy. So how do you make use of this data? Is it safe? Is it appropriate to collect this data? Then there's huge concerns about the scope and the quality of the data. So for example, in my organization, we have over 200 computer systems, and they all have their different definitions of how to, for example, talk about gender. I'm very mindful that gender is a very complex topic, but if in one system a woman is a 1 and another system a woman is a 2, then of course they can't talk to each other in that particular way. The third one is the theoretical and educational foundations. Even if you have lots of data, what does it mean? Lots of studies are also worried about research, that there's not a lot of research done. Then there are lots of studies and practice that shows that there's not a lot of practice. Okay, we can talk about learning analytics, but no one actually is using it. And then the sixth one is how do you focus on this on an institutional level? So are institutions actually using it, or is it that one teacher in computer science that has learning analytics in their portfolio, but actually no one is using it at all? And then last is the measurement of impact. So I'm going to go for another round. So who is mostly worried in their institution about the ethics and privacy of all this data? We have one, two, we have a couple. Oh, actually, much more than, okay, so lots of you are worried about this. And I think this is a huge concern. Who is worried about the scope and the quality of all this data that you have in your institution? Yeah, a couple, 20, 30, yes. Who is worried about this, the theoretical and educational foundations of all this data? Yeah, a couple, okay. Who is worried about the lack of research? No one is worried about this. Oh, there are a couple. Okay. Who is worried about actually doing it in practice? Okay, much more. So currently it's ethics and practice. Okay. And who is worried that on an institutional level, it's great that this one teacher in computing is doing it? Okay, yeah, a couple. And last and not least, and this is my favorite, I hadn't mentioned this, but every time when I go to the vice chancellor, says, yeah, where's the impact? Where's the evidence that this works? Okay, so I guess it's ethics. It's about practice, and it's about the measurement of impact. So where are we at the Open University? So if you're worried about ethics, there's a free open education resource available about how to use this. We're the first university in the world to have this ethics policy in place. But you're completely right that in terms of practice, there is some good measurement out there, at least within the Open University, but mostly this practice, this evidence is nested within small units, not across an entire journey of our students. And in terms of practice, I think there's a lot of need, at least within our own institution, of why do teachers and students perhaps not always make the best use of this. So I've talked a lot already about learning analytics, and of course learning analytics includes artificial intelligence. But with the rise of Gen AI, of course, you have to talk about Gen AI. So I didn't color this picture orange, I forgot. But who is not familiar with this Rienties model? Who has not seen this model? Okay, but most of you have seen this. So it's basically 4 pillars of how AI is being used in education. And I've colored basically where we at the Open University are primarily focused on. So yes, on the left-hand side, we've done a lot of work on predicting. We've done some work on assessment and feedback, and we're currently mostly focusing, I wouldn't say that intelligent tutoring is the best word, but we're currently working on an AI assistant that basically we're testing as we speak. Which is very exciting. I would love to demo it, but yeah, I'm not sure this would be a wise thing. So I'm just going to share some screenshots with you. So what we've been implementing, and this paper has just been published, is we are currently working on a range of AI tools that give teachers and students the opportunity to automatically create AI content in a safe space within the Open University. So our core asset, this is also linked to Antonio, our IP. We spend so much time developing our amazing materials and content. We don't want to give this for free to ChatGPT, right? So we're basically playing with a kind of safe space that we created ourselves. And one of the ideas was, for example, flashcards, giving flashcards to students. Do you understand a particular topic? Another one, this looks like a human being. This is actually an AR avatar. This is one of our professors, John Demeng. And we gave these avatars to our students. And we were keen to hear from them, do they like this or not? So when we asked what are the 4 services that students would expect from Gen AI, from such kind of approach, they came up with 4 big elements. So one student basically mentioned, it would be great to have this 24/7 support, because I tend to work at different times than my tutor. So I could just ask that person, that AI assistant, hey, I'm struggling with this, where can I go? The other student, for example, mentioned, okay, it would be really nice to find additional resources. So when I'm working with the AI tutor, it could give me indications where I would have to go next. Another student mentioned it's sometimes tricky for me to revise. So having an AI tutor would basically, the tutor would know exactly where I am and what I do well and what I don't do well. So in 4 times of services that these students were initially stating, and this is just, I'm very mindful, the number is very small, it's just 8. But we replicated this study with 100 students this summer, and currently a survey is live, and already 250 students have filled this in. And the results are more or less the same. So what they're looking for is some kind of real-time assistance, and they're looking for a tool that gives immediate query resolution. So the tool should know, oh, I'm in week 4.2, I'm very bad at math, so give me more math exercises in week 4.2. The other element is this personalization and accessibility. So, for example, I personally love diagrams, and I personally like to, get a deeper understanding. So it would be really nice if my examples also include a lot of diagrams. Then it would be very useful to focus on academic tasks. So students were saying, I don't want to have a friend. I just want to have an AI digital assistant that helps you with my academic tasks. But surprisingly, around half of the students indicated they also wanted to have some kind of emotional and social support. And when we replicated this with a larger study, it's a little bit like the English expression is like Marmite. You either love it or you hate it. So some students absolutely would want to have this friend, and others were really appalled by this idea. So what were the concerns from the student? So one of the biggest concerns, for example, a student is that it knows so much about you, and this particular person was afraid that it would replace humans. This links perhaps again back to Antonio. It's like in 10 years' time, when we have all this AI chatbots with Industry 4.0, would people like me still be needed if an AI digital assistant does such a better job than me? Another person wrote, and I thought this was a really good quote, he works as a financial controller in a large clothing company, and he was worried that eventually all these people will be replaced with computers or with AI bots, and then he was wondering about his daughter and about what's going to happen to her. What kind of job will she have in 10, 15 years' time? And another student was really worried about, what if my work is rubbish, and then the AI chatbot builds their models based on my work and gives wrong advice to others. So these are some of the concerns that the students mentioned. So what I would like to discuss a little bit with you is to think about how you in your own institution are working with an AI assistant or not, and whether we should allow this AI assistant to freely roam across all kinds of digital resources across the internet, or perhaps whether we should develop this walled garden, that it basically is only allowed to work with data from your own institution. And you could argue that with the speed of development of ChatGPT and similar products, maybe we shouldn't do this walled garden. Probably the tools that we're currently developing are probably so inferior to ChatGPT. Why even bother? So I guess what I was wondering, and again as a kind of voting, is do you think it would be better to think about your own institution? Do you think it's better to just buy off-the-shelf AI systems, or would you prefer that? Or would you prefer that it's more kind of a walled garden approach? So who is more for? Okay, let's just use all the tools that are publicly available. So I'm just going to stand here on the left-hand side. Who is more in favor of this? Only a couple. I'm surprised. Okay. Who is more in favor of, okay, as institutions, we should focus more on kind of this institutional walled garden? Okay, who hasn't voted? Okay. Anyone want to shout out why? Both. Mix. Oh, but how is it possible, a mix? That's impossible, right? Right, come and chat to me afterwards. I'm mindful of time. I have 9 more minutes, so that gives me a little bit of time to talk about my favorite topic. My favorite topic is learning design. So what I've been talking about a lot is data, data, data. But if you don't really know how you design your educational courses, all this data is useless. So what you need is real deep understanding of how your teachers are designing courses. So who has not seen this graph before? Most of you have seen this before, okay? So for those who haven't seen this before, I've been doing this for quite some time, so this is nearly 9 years old. We mapped how over 150 teachers across the Open University design courses at the Open University, and there are 4 types of teachers, crudely. One designs lots of materials and lots of individual learning, so-called constructivist design. One designs a lot of assessments and gives a lot of feedback. A third one gives a lot of doing stuff, which we call productive. And the fourth one is social constructivist learning. And what we have done and seen over the years is that the way how teachers design their courses fundamentally drives student behavior. So what we, for example, see is that if you design lots of social constructivist learning activities like student to student, teacher to student, student to teacher, this leads to much more engagement of your students in your courses. While if you, for example, design lots of amazing materials, but just amazing materials, this has a negative effect of student engagement over time. But if you look at, for example, this small thing called student satisfaction, the #1 predictor of whether or not students love your course is giving them lots of materials. And the #1 negative predictor for student satisfaction is, at least at the Open University, is whether students have to work together. But it is the #1 predictor of student retention. So in our courses which are open, the biggest worry is retention. So we've always been struggling to square that circle. Should we focus on satisfaction, or should we focus on retention? And in some of our studies, this is a scary looking graph, but in our studies we continuously show that more than 2/3 of what our students are doing on a week-by-week basis is determined by us. We as teachers basically drive our students. The way how we design our courses fundamentally impacts our students. So when I talk to amazing educators who say, yeah, the students, they're not working hard enough, I always put this in front of them. Because 2/3 of what students are doing is determined by us as educators. So if you're interested to improve your courses, and this is a shameless plug, we've made a free tool available for any educator in the world. This is developed together with the European Union in a range of universities. And this tool automatically allows you to map your learning design, and the URL for this is learningdesign.eu. And if you play with this tool, it automatically provides all this real-time analytics of your courses. And if you come to my workshop later, we will also play with this tool. And we have learned quite a lot from this already, and it's really fascinating. We have a lot of users using this system, and the surprising thing is that most people find it really easy, which is the most exciting thing. And last but not least, and I'm very mindful of time, I saw an amazing bridge here with the swan neck. So if you're interested in learning analytics data, there is another bridge you can visit, and this is a shameless plug. We're organizing the next Learning Analytics event in Dublin. So if you're interested in learning analytics, come to our Learning Analytics event in Dublin. So thank you very much for your attention, and looking forward to seeing you at the workshop.
Okay. Thank you. So now is the time of Bart Yongpradit. Bart Yongpradit is the Chief Academic Officer for Code.org, a nonprofit dedicated to promoting computer science education, and lead of Teach AI, a global initiative to guide education leaders in rethinking education in an age of AI. He's certified in biology, physics, math, health, and technology education. Sir, the floor is yours.
To see you. My name is Pat Yongpradit, and I have a gift for you. I saw a lot of you were taking out your phones and snapping pictures of Bart's wonderful slides. And I know how that could be tiresome after a while, so I've given you the slides themselves. So this is a QR code to my LinkedIn, because not only did I put my slides there, but I put my main points in there in case you forget what I say and you want to review them later. But actually, I provided a link to my LinkedIn because I actually want to interact with you after this keynote. So even during this keynote, you can ask questions, put your takeaways into the comments for that post, or you can just grab the slides as well. I also put some links into the comments so that you can just click on those versus having to type on things. All right? So that's a QR code to my LinkedIn where you'll see this keynote presentation, and I'll show that later. So a little bit about me. I hail from Washington, D.C., and before I became the Chief Academic Officer for Code.org, I was a teacher. I taught for 13 years in mostly secondary school, middle school and high school in the US, actually in Silver Spring, Maryland. And this is a picture of me with some of my students. And I always show a picture of me and my students because it reminds me of what we're doing here. All of us, whether you're in higher ed or primary or secondary education, are all about students. And so it's wonderful that you're coming here to figure out how to do your jobs better so that you can serve your students better. I am the Chief Academic Officer for Code.org, and if you haven't heard of Code.org, Code.org is a civil society organization, a nonprofit organization based in the US with international influence. And our vision is that every student in every school has the opportunity to learn computer science and AI. The problem is, in the US, but also internationally, there are still hundreds of thousands of students who couldn't take computer science, computing, informatics, whatever you call it, even if they wanted to. And in an age of AI, computer science, informatics, computing, it's more important than ever. So, with the AI hubbub for over the last, about 2 years now, a group of organizations got together to decide to do something to guide education leaders and policymakers. So 5 organizations got together and created an initiative called Teach AI. You can visit it at teachai.org. The whole purpose of Teach AI is to guide education leaders and policymakers in rethinking our education systems in an age of AI. The goal is not to integrate AI in education, but to transform education, potentially using AI. And I'll talk about that potentially later, but certainly using AI as a context. And those organizations are Code.org, ETS, ISTE, the International Society for Technology and Education, Khan Academy, and the World Economic Forum. There are actually over 100 advisory committee organizations, including informatics societies from around the world, including Brazil, Portugal, Spain, as well as the World Bank, the Association for the Advancement of Artificial Intelligence, but even OpenAI, Google, Microsoft, Amazon, Meta, etc., all working together. And we're called Teach AI because we believe in teaching with AI and about AI. I'll talk about this. If you're new to AI in education, this is an easy way to categorize what AI in education is all about. Let's start with teaching with AI. Teaching with AI is all about using it as a tool across various subjects. It could be teacher support, it could be for student learning, it could be for school management and operations. Here is a video of the teacher tools available at Khan Academy. And this is a particular teacher tool, a lesson planning tool, which is oftentimes a very tedious aspect of teaching. And so in this case, they're using a wrapper on top of ChatGPT to prompt the development of a lesson plan and actually refine that development of a lesson plan based off of interest in Taylor Swift, actually. So that's one example. Then there's teaching about AI. Now, teaching about AI often gets overlooked because AI itself is a discipline, as well as it has connections with lots of other disciplines as well. Those disciplines could be informatics, ethics, mathematics, psychology, et cetera, et cetera, et cetera. In fact, many of you don't teach AI mainly, but you do teach AI as part of another subject. And so how AI works comes from these subjects and more, but knowing how AI works helps you use it more effectively and responsibly. Knowing how AI works helps us get beyond the superficial layer of understanding the ethical and social implications of AI to get to the deeper understandings, the deeper ramifications, the understanding why those things are issues. We'll talk about some of those issues in a sec. But let's get to this main point of AI literacy and talk about what it is. So what does it mean to be AI literate? Well, it means many things. And in fact, a number of people around the world are working on this, including Teach AI, which is working on an AI literacy framework with global partners. So look out for that. But what is AI literacy? It's, first off, recognizing the presence and role of AI all around us. You know, AI, generative AI especially, is being woven into so many different things. I was on my phone today and taking a picture and thinking about the role of AI in just creating the standard picture that I have. So not even a filter, not a special feature. In fact, the new Google phones, you're able to prompt an image model inside the photo app and change the background altogether. So if you have one of those new Pixel 9s, you can do that. And that's obviously generative AI, but there's already AI involved in just taking a picture. So no longer, you might think, no longer do we have the ability to tell the difference between fake photos and real photos. Guess what? Your photos are already fake photos. So recognizing that is important. But also deciding whether an AI approach is even a responsible approach for a problem. That's AI literacy. Understanding how to formulate a problem. My colleague at King's College London, Oguz Akar, talks about the difference between prompting as a problem-solving technique and problem formulation, which is actually more significant and more durable in an age of AI because, as we've seen over the last 2 years, prompting gets easier and easier and easier. What else is AI literacy? Understanding AI's capabilities and limitations. Now, Bart did this thing where he had you raise your hands, and I don't want to embarrass anyone, so you can just raise your hands in your head for these next 2 questions, all right? But the first question is, have you used a generative AI tool at all? That's the first question. Okay, and some of you raise your hand. Okay, great, wonderful. You don't have to, all right? The next question is a little bit more personal. I know there are a lot of educators in this audience. You don't need to raise your hand, okay? But have you given official guidance to your students on how they should use AI? Have your institutions done that, if you've done that? Who knows, right? That is what builds AI literacy, just understanding when to use it, when not to use it, the capabilities and limitations. Critically evaluating AI's outputs, which, by the way, differ between subject. Because if you're in computer science, computing, informatics, the use of AI is going to be very different. Plagiarism is going to be very different because it's almost required when you're coding to plagiarize from other bodies of software knowledge. But when it comes to a creative writing piece, using an AI chatbot to create writing and text is very different. So ultimately, what does it mean to be AI literate? We're going to talk about the how AI works side today. And we're going to focus on informatics. Now, I'm going to focus on informatics because I want to move away from the general AI in education topic. I cannot wait till the day when we're moving beyond the idea of, is AI good, is AI bad, or is AI both in education? Because the fact is, it's everything. It's good, it's bad, it's extremely bad, it's extremely good. And we have to get very nuanced, not just within a particular subject, but also use cases within that subject. And so I'm going to talk about informatics, and I'm going to talk about how the informatics community is engaging and wrestling with AI's role in the informatics classroom. But since I'm a teacher, I have to start off with a little AI literacy for you, which is a brief introduction into how AI works. Now, I apologize if you are a professor of artificial intelligence out there, because I'm going to oversimplify, but I know that there are some people in this audience who've probably listened to webinars, podcasts. You might have even spoken about AI to other people, but you really, really don't know how AI actually works. So I'm going to hit it at a high level just to set the stage for the rest of our conversations over the next 2 days. Because I was actually reading the schedule, and I saw that there were 7 breakout sessions, all about AI in some way, explicitly. And of those 7, there were 39 papers. In fact, a number of you have written papers about AI. So again, I apologize for this oversimplification. So let's start off with a definition. AI refers to programs or machines that simulate tasks that typically require human intelligence. You might think, boy, that's super broad. It is super broad because AI as a field is just a super broad field. So you have to actually get deeper. And so whenever you're defining AI, it always pays to talk about key examples. And these are 3 key examples: making predictions, generating content, providing recommendations. Notice, I didn't say anything about making decisions. And that's a key thing that I do not do, because I don't want to ever be accused of anthropomorphizing AI or lifting AI's role above the human role, because we are the ones who are going to make the decisions or should make the decisions. AI can provide the recommendations, AI can make the predictions, but I'm the one who's going to make the decisions. So if you're an educator using AI as a grading tool, you need to be the one making decisions. So, in talking about AI, it helps to start off with a simple program. Imagine a program where a student is learning, imagine a program that asks you what your symptoms are because you're coughing, and then asks you subsequent questions. And imagine these if-else, if-then questions and if-else, if-else-if questions being nested. And imagine hundreds or thousands of these. You can imagine that this simple program could start to approximate medical expertise. But the problem is, I had to type in everything all myself, and it can only do one thing. This is called classical AI, AI from the 50s and 60s. But then came along this idea of teaching machines to learn patterns. And we call this machine learning. And this is the basis for the AI, much of the AI that we know today. Now, it's not the only technique in AI, but it is the predominant technique right now. And it requires really big computers. So it couldn't really happen in the 50s and 60s. We had to wait till computing power caught up. And then we have to give it, rather than the rules, we had to give it algorithms for learning relationships among pieces of data. Lots and lots of data, in fact. And so the machine is now learning all these relationships itself, and that is the basis for what we see as autocomplete text, video recommendations, email filters, translation apps, etc. Machine learning. Now, how did we get to generative AI? Well, we go through the technique of deep learning, which is basically, you can just consider it really, really strong machine learning. And you give it all the data on the internet, and then you can get large language models. The ability to model language itself. Now, this is the key point, folks. A lot of students are using generative AI these days. I was reading a Digital Education Council survey report from just July 2024, and they said that 86%, and I think this was mostly higher education, 86% of students are using AI. 58% are using it weekly, and 24% are using it every single day. And the thing is, I bet you a number of them don't really realize what a large language model is. In fact, 69% of you use AI to search for information. And here's the problem, and I know that some of you all know where I'm going with this. A large language model is not a fact machine. It's not a fact proxy machine, in fact. It's just for the purpose of creating language that is plausible, that makes sense. That's why it's a large language model. It models language. And so the output is about modeling something that makes sense and looks like fluent language. That's why when you use a chatbot, you're like amazed by it. Wow, it's so fluent. Yes, that's what it's designed to do, but it's not designed for fact. And so it's a problem when 69% of students who use Gen AI use it to search for information. So generative AI has a lot of issues with it. And it's much more than just text. It's image, videos, etc. And the issues relate to transparency and explainability, trust and accountability, etc. But now you know why those issues are issues at a technical level. For example, transparency and explainability. I showed you that fancy picture of all those algorithms. But those algorithms and the relationships that they create among data, the programmers don't even know what's going on. They don't know what's going on. It's a totally different way of programming, where you didn't type in all the rules yourself. That has issues with transparency and explainability. There are also issues with bias, because guess what? If you're pulling large and large amounts of data, you know where I'm going with this. You know that there's a lot of bias in that data. There's a lot of racism, sexism, etc. in that data. Do you think that the AI model creators are able to filter all that out? No, you actually can't. And in fact, in some cases, you may need that sexist data, because depending on what you're asking the AI chatbot, it's information. So that's where the bias comes from, and now you know some of the technical underpinnings. Let's talk about what it means in the informatics classroom. Here's a tool that's being used very often in informatics classrooms. It's the GitHub Copilot. In fact, you can find this type of tool. You can actually use ChatGPT itself to do this kind of thing. But writing unit tests in an informatics classroom can often be a tedious aspect of the coding process. So why not use a chatbot for that? Here's the problem. If you can ask a chatbot to create a unit test, which tests code, you can ask it to create the code itself. What's stopping kids from just cheating? In fact, forget cheating. Why is it important to learn to code anyway if a chatbot can do it? It seems to do it pretty well, right? Well, this question was asked of NVIDIA's CEO, Jensen Huang. He was asked this very question. He was asked, so what should kids learn in an age of AI? Let's see what he said.
Let's move to a non-AI related topic for a second. I want to talk about education. So today, knowing what you know, seeing what you see, and being at the cutting edge of this technology, what should people focus on when it comes to education? What should they learn? How should they educate their kids and their societies?
Wow, excellent question. I'm going to say something, and it's going to sound completely opposite of what people feel. You probably recall, over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program. And that the programming language is human. Everybody in the world is now a programmer. This is the miracle. This is the miracle of artificial intelligence. For the very first time, we have closed the gap, the technology divide.
Okay, enough of that, Jensen. So you might be thinking, oh, wait, Pat, why did you show a video like that? It makes it seem like the whole point of your keynote doesn't have a point in an age of AI. Well, first off, Jensen isn't an educator. But that doesn't mean that he doesn't have a point. Now, educators could look at that and think, no, it's still important to learn to program. He doesn't know what he's talking about. He's just a tech CEO. But the fact is that he does have a point. And what all academic communities should do these days is question, why are we teaching what we're teaching in an age of AI? And so we're going to get into how the informatics community is wrestling with some of these questions, starting with that question, why is it still important to learn to program? Again, I'll be talking about computer science, computing, informatics, but I want you to think about your fields, whether it's a humanities field, a STEM field, etc. Why is it important to learn, to teach what we're teaching? In fact, you should ask yourself the question, what is the most important thing to teach? And then ask yourself the question, is it still important in an age of AI, and what else might actually be more important? So let's look at what the computer science education community is doing. The first thing that they're doing is realizing that, for AI, for robotics, for cybersecurity, for data science, for a lot of things, computing remains fundamental. It's foundational. It teaches things like ethics, algorithms, data programming. So just at a base knowledge level, it's required. It's important. It's foundational. But what is foundational now? That's the question. What is foundational? Is the coding aspect of informatics still as foundational as it was? And so a group of people got together, from all over the world, in fact, to create this guidance on the future of computer science education in an age of AI. And Teach AI partnered with the Computer Science Teachers Association, which is a global organization for computer science teachers. And the purpose of this guidance was to realize the benefits and mitigate the risks of AI in computer science education. It was to broaden participation in computer science education and figure out how to use AI towards that goal. The purpose was to modernize computer science curriculum and instruction and not shy away or bury our heads in the sand when it comes to AI and its effect on computer science. But it was also to provide an example for other disciplines. So you could imagine that you could erase the word computer science or informatics and include your subject. So are you thinking about this? Is your academic community thinking about this as well? Let's take some quick lessons learned from the computer science community. Starting with number 1. We addressed multiple myths in this guidance. And the first myth is that AI coding tools make programming, knowledge, and skills unnecessary. And the fact is that in an age of AI where kids are using these AI tools, the AI tools don't make learning to code unnecessary. In fact, learning how to code at a foundational level first helps you use the AI tools better. And so this is the common situation between, does AI replace a task or does it augment a task? And in fact, with coding, you're going to see a little bit of both. This is what I mean by the nuances. So if we're still, as an academic community, as a global academic community, thinking about whether AI is good or bad for learning, or will AI replace or augment learning, that's still too broad. We need to get more specific. We also dealt with this particular myth. AI can program accurately and independently. Sorry that this got cut off a little bit. And that's a myth, because as we know, code generators produce correct code between 31 and 65% of the time. And even if they were perfect, the purpose of coding is not just to create the code. You have to embed the code within an existing larger program. And AI can't do that yet. Here's another myth. AI will replace all programming jobs. The fact is that AI will shift the focus of programming jobs. It will change it. And yes, some aspects will be de-emphasized, like rote coding on your own. But code reading, evaluation, debugging, and refactoring, these things will be more important. Now, how does this impact your discipline? Well, let's say you teach a language. Let's say you teach creative writing. Well, maybe there are certain aspects of creative writing that will be de-emphasized. Should ideating and just coming up with ideas be de-emphasized? Should that be emphasized and actually writing drafts? That should be de-emphasized, and editing is emphasized, right? It changes different aspects of the creative writing process. Here's another myth. The only purpose of learning to program is to produce programs. And in fact, learning to program is very different at the primary and secondary and tertiary level than the professional practice of programming, which is mostly about producing programs. Because when you're learning to program, you're learning many other things as well. You're learning logic, you're learning how computers work, you're learning persistence, resilience, you're learning collaboration as well. And so the reality is that programming promotes many other things, including creative expression, and even just discovering joy, human agency in creating things ourselves, powerful things. These are important aspects of programming that go beyond just creating a program. AI coding tools are the only way to use AI in the informatics classroom. You know, as you saw that there were some tools that I put up above, these aren't the only types of tools that you can find in the coding classroom. So that's a myth. And in fact, teachers, this was a survey from the guidance, teachers understand the intricacies of using these types of tools. And they actually are kind of, they have mixed opinions about introducing them to novice students, which is a good thing. That's per the coding tools. But those coding tools are not the only types of tools. This is one of my favorite tools that's out there right now. It's out of Harvard's Creative Computing Lab. It's called Block Talk. And it uses a generative AI chatbot to simulate helping a student debug their own program. And so the teacher is actually typing in these things and with a simulated student. And it helps a teacher practice their debugging conversation pedagogy. So the only coding tools are not just the actual code generators. You can have teacher simulations as well. And this obviously applies to other subjects. A couple more myths. Informatics teachers don't want to teach a new topic. We might be thinking, oh, you know what? They already have so much to teach. Well, in fact, they really do want to teach about AI. And you might be thinking, well, that's obvious. They're informatics teachers. Of course they want to teach about AI. But do English teachers want to teach about AI? Or do these informatics teachers, do they want to teach about the other aspects of AI, like the ethical and societal impacts? The answer is yes, they actually do. It's a myth that they don't want to teach about larger, more broader societal aspects of computing, because we ask those same teachers whether they're teaching about bias, misinformation, et cetera, and guess what? They are. And actually, most of these computer science teachers discuss AI ethics with students weekly or monthly. They're really leaning into this. And other academic communities need to lean into this too. So I'm going to end here with with this quote and then a call to action for you all. This quote is from the board chair of the Computer Science Teachers Association, and basically Charity says that as a computing community, we need to understand our opportunity and responsibility for leaning into AI and teaching about the broader implications of AI, not just the technical aspects. That goes for you too, whatever your discipline. If you're already teaching about ethics and societal implications, teach about the technical side. If you're teaching about the technical side, teach about the other side as well. We all have a role to play in AI literacy, not just informatics teachers. So in conclusion, AI literacy, yes, it requires informatics. Teachers need to understand how AI works so that they can teach kids how AI works. But it goes beyond informatics. AI literacy requires you all as well, whatever your subject. I'm going to have a workshop after this that's going to go into the details of how you can implement AI in your discipline, how you can implement AI literacy in your discipline, understanding that not all of you are informatics teachers. Though, by the way, I looked at some of the tracks. I'm very excited to connect with my informatics and computing peers out there. But AI literacy requires all subjects. So please connect with me. Connect with me if you just want the slides. I'd love to hear your takeaways and your questions and what you learned from this. And also, attend my workshop, attend Bart's workshop later on, and attend all those other sessions about AI sprinkled across. Thank you.
Thank you, Bart. Thank you, you both. You made this plenary really successful. I've been looking at the faces of everybody here. You see the room is full. They were following you. This was really great. 2 seconds left in your presentation, so it cannot be better. So I know you have a lot of questions, but I think they both deserve a coffee break. You too. Okay, so first, now it's time for coffee break. You charge your batteries. You have plenty of sessions in front of you. Thank you, everybody, for being here.